Hey everyone, and welcome back to your math class and lesson 15. Today we're going to start talking about problems involving two variables. So we're still working on algebra, we are still dealing with variables, but now we're going to make it a little bit more complicated and add in a second variable. So let's dive right into the plan for today's lesson. So first things first, we're going to do a little bit of housekeeping. I've decided to just basically due to some scheduling stuff on my end, I've decided we're not going to do the test this Thursday because this lesson is being recorded a little bit later than I would have liked. Like I would have wanted this to be last Thursday's lesson instead of this Tuesday's lesson. And so as a result, my original plan was to go over this lesson last Thursday, do a test review today, and then have the test on Thursday. But since we don't have that time really before Semana Santa, I'm going to just carry on with the lessons as they are right now. Maybe we'll spend an extra lesson working with two variables so that you get the extra practice in. And then after Semana Santa, we'll decide on a date for the test. It'll probably be like the first Thursday after Semana Santa or something like that, but we'll figure that out a little bit down the road. After that, for today's video, we are going to learn how to solve problems when we have more than one variable. So that's not that you've got like the same letter, like x, showing up once, twice, thrice in the same expression, but you've got an x over here and you've got a y over here. You've got two different unknown quantities and you need to figure out what both of them are. So we're going to figure out how to solve problems like that. Once we've figured out how to solve problems like that and gone through a couple of examples, you're going to get some practice questions, and then we're going to do a word problem together at the end as well. So let's dive right into the housekeeping. So like I just said on the previous slide, we will not be having our test this Thursday. It's going to be sometime after Semana Santa, but I will decide on the exact date shortly, and that should come to you either this Thursday or after Semana Santa. If the date of the test, I should be able to have that all sorted by this Thursday. I just need a little bit more time to plan everything out in my head and get it all organized in my calendar. So don't worry about the test right now. Do try and review your notes over the break so that when you come back, it's not like you've taken a 10-day vacation from these concepts, because then it's going to be hard to start it back up. I want you guys to have your time off and have your fun during Semana Santa, but if you take just like, I don't know, 10 minutes every other day to just go through some of your notes. What did we talk about? What did we learn? You know, come back to the videos or one or two of the videos or something and go through them at like a higher speed so that you don't need 40 minutes to finish them. Just a little bit of time here and there over your break so that you keep these concepts kind of fresh, and then we'll come back to it all after Semana Santa. And then, of course, there will be a review session before the test, so you will know exactly what you need to study, exactly what you need to know. And my schedule right now, I need to take a couple of glances at it to see how it's all gonna work when I get set up in a new town that I'm going to. But once I get that set up, I'll decide on dates for live review sessions like we had for the last test, because I think that was helpful for at least some of you. So we're definitely going to do that again. I just need to figure out the dates and times that'll work. So without further ado, let's get into today's lesson. So now we're getting into algebra problems with multiple variables. So the thing you see on screen here, this picture, is something that you might have seen a lot of on social media, Facebook, Instagram, something. I know I definitely did when I was younger. You'd see a lot of this stuff on social media. And at the time, it was like, oh, let me figure out what the apple must be equal to. If 3 apples added together equals 60, that means the apple is 20. Oh, this is so much fun. And the thing is, a lot of people would actually solve these problems on Facebook. You're just scrolling through Facebook and then you're presented with a challenge like this. Can you solve this fruit math puzzle? And then everybody's writing in the comments of what they think the apple is worth, the orange is worth, and what the banana is worth. And it's interesting because if you do it like this, if you make it look like a game, if you make it look like a puzzle, if you put pictures instead of letters, people are happy to solve it. But this is an algebra question with 3 different variables, right? You got one variable that's the apple, one variable that's the orange, and one variable that's the banana. And you could have written this as x plus x plus x equals 60, x plus y equals 30, y plus z equals 9. You know, you could have written it with letters. You could have done A for apple, you could have done O for orange, but that would look like a 0. You could have done B for banana. You know, you could do whatever you want and turn it into something that looks more like the algebra that we've been doing, where you start putting letters in and then you're dealing with like bedmass and this and that. Like, you could absolutely have questions like that built out of letters instead of built out of pictures. And the interesting thing is, if you've ever solved a question like this, you might not have realized it at the time, but you were doing an algebra problem, and you were doing an algebra problem with multiple variables involved. So today we're going to be talking about how to solve problems with 2 variables, but if you've ever solved something that looks pretty much like this on screen, you might have solved stuff with 3 or 4 variables by now. So let's talk about how to actually solve problems with 2 or more variables. So in order to solve a problem with 2 variables, you need to have 2 separate equations with information about at least one of the variables in each case, right? So you'll have, like, let's say one equation that says like x plus y equals 12. That's like, okay, because they're both unknown numbers, if I have x plus y equals 12, I could say that x is 6 and y is 6, because 6 plus 6 equals 12, but x could be 5 and y could be 7. Add those together to get 12. Could be x is 11, y is 1, add those to get 12. So I don't have enough information to know exactly what x must be equal to and what y must be equal to. So the first equation of x plus y equals 12 gives me some information, but not enough information to solve the problem. I need one more piece of information that tells me something, that either, you know, y is this much bigger than x, or x is 2 times y, or, you know, I need something to go on so that I can figure out, okay, now there's only one number that makes sense for x and one number that makes sense for y. And so basically the idea when you're solving problems with more variables is, for every different variable you have, for every different letter that shows up in your problem, for every different fruit that shows up in your problem, you need to have that many equations in order to solve the problem fully. So if you have a problem with 2 variables, you need to see 2 different equations that contain different pieces of information. To solve a problem with 3 variables, you need 3 equations that contain different pieces of information. So generally speaking, if we were to say instead of 2 or 3, if we were just to pick a letter to represent that, whatever that quantity is, and we say that's n, then to solve a problem with n variables, you need to have n equations. So that means that if n is 5, you have 5 variables, you need 5 equations. N is 12, you need 12, you have 12 variables, you need 12 equations. So as you can see in the fruit math puzzle, we've got the apple, the orange, and the banana. Those are our 3 different variables, and they've given us 3 different pieces of information. Now I keep saying different pieces of information, right? Because if I say apple plus apple plus apple equals 60, but then I say, I don't know, 3 apple, like 3a, equals 60 as a separate equation, that's not giving me new information, because that's the same thing as what this first line is telling me, right? If in the second line I said apple plus orange equals 30, but then as a separate equation I said apple plus 2 orange equals 30, I've written it a little bit differently, but I haven't given any new information. So it's not helpful if the equations are giving the exact same info. So you can see in this first one, it's just talking about the apples. The second equation is talking about the oranges. So there's some new information being provided because we've got to learn something about the oranges now. And then the third equation has some new information about the bananas. So the equations all have to have some sort of different information contained within them, but we won't worry about that just yet. The key right now is, first things first, you have to make sure that if you're, however many variables you have in your problem, you need to have that many equations as well. So when it comes to solving problems with 2 variables, we know now that we need to have 2 equations. So when we're doing the practice questions together, or rather, when you guys are doing any practice questions that aren't word problems, I'm just going to give you both equations right there. So you're never going to have to worry about making sure you have enough information. That's my job. So the thing is, you're going to have two equations in front of you. You can call them equation 1 and equation 2. You could write a 1 in a little circle near one of the equations and a 2 in a circle near the other equation. So you have these little labels for both of them so that you can talk about them by saying like equation 1 and equation 2 instead of having to say like the left one and the right one or like, you know, something weird. So here's the idea. Here's the steps you need to follow, and we're going to understand the logic of it when we look at an example. So using one of the equations, pick your favorite, pick the one that's less complicated, isolate one of the variables. So hopefully we remember what isolating means. That means you'd get one of the variables by itself on one side of the equal sign, and then all the other stuff is on the other side of the equal sign. So if you've got, like we were saying with x plus y equals 12, we've got the x and the y together on one side. That's not good enough. We need to pick either the x or the y to keep by itself and move the other one over to the other side of the equation. So for instance, x plus y equals 12, you could write instead as x equals 12 minus y, right? That's the same thing. Now, after you've done that, like why would we do this? This is a good first step because we've seen isolating variables before. Now, the reason that we do it like this and we have the other variable sitting on the other side is that when we look at our second equation, it might have some more information involving both variables, but I now know from this type of expression, x equals 12 minus y, I now know that every time I see an x in the other equation, I can write down 12 minus y, because we know from this equation right here that x is equal to 12 minus y, right? So that means that in the other equation, whatever it is, because we haven't done a real problem, I'm just making stuff up, right? In the other equation, if it's like x equals 2 times y, I can replace every place that I see an x with 12 minus y. So it becomes a problem of just one variable. Now this is a little bit weird to see without an example, so let's do an actual proper example, and hopefully that'll paint a better picture. So basically, the only things you need to remember are the things that are on the previous slide there, which are number one, you need to make sure you have two equations if you've got a problem with two variables. You need to isolate one of the variables and then substitute that result into the other equation. So let's see that in this example. We're being asked to find the values of x and y. So we've been given these two equations. Both of them have an x and a y show up, like, you know, they show up in each of them. It's not that one's got just x or just y and the other one has both. This is your complicated type of problem where you've got an x and a y over here, you've got an x and a y over here. Now, the nice thing with equation 2 over here, so if I were to label these, I was envisioning that you label them something like this. Put a 1 in a circle over here, put a 2 in a circle over here, something like that. So we've got equation 1 and equation 2. Now, equation 2 has already isolated y, right? Y is by itself, it's got no minus signs, got no numbers, not being multiplied, subtracted, anything like that on the left side of the equation, and then all the other stuff is on the other side of the equation. So we've got this 28 minus x is on the other side of the equation. So from equation 2, where we've isolated y, we know that y is exactly the same thing as 28 minus x. We just know that that's what this equation is telling us, is that anytime you see a y, that can be written as 28 minus x. So now that's the piece of information that we've pulled out of equation 2, is we know how to write y using only x's and numbers, without using y again, right? So we know that y can be written, we say, in terms of x. We can write y using x's and numbers. So in equation 1 now, so because we started with looking at equation 2 and isolating y, which was already done for us, we go to equation 1, this EQ, that's just short form for equation. So we go to equation 1, this x plus 3y equals 40, and where we see this y right here, x plus 3y, that y we're going to replace with 28 minus x, because we know that y is equal to 28 minus x. So we'll put the 28 minus x right in there where that y is. Now it's being multiplied to the 3, so we still have to make sure we're doing that multiplication, right? So we're going to have to put the 28 minus x in brackets, because if we don't, then we're not going to multiply the x by 3. Like it gets a little bit weird if you don't put it in brackets. So as a good practice, whenever you substitute in the value for one of the variables that you got from the other equation, just put it in brackets to be safe, because it's all one unit that way. So we get x plus 3 times this whole thing, 28 minus x, equals 40. That's from equation 1, but the stuff in blue right here, actually not the entire thing in blue, but everything except the 3, so all of this is just what we said is equal to y from equation 2, right? So that's where we got that. Now, if we go through solving that, we get x plus 84 minus 3x equals 40. So what's happening here is this is the distributive property, which hopefully most of you will have seen before. If you haven't, we're going to talk about it briefly on the next slide. But basically what happens is you're taking this 3 and you multiply it separately by everything that you see inside the brackets. So if you've got a number on the outside and brackets with a bunch of stuff on the inside, you take the number on the outside and you multiply it individually by every single thing you see inside the brackets. So what we've got going on over here is we had x plus, and then we've got 3 times 28, which is 84, minus 3 times x, so that's 3x right there, equals 40. So hopefully that makes sense. We're going to look at the distributive property again in just a sec. But then you isolate x, because you've got all this stuff going on, so I'm going to just shuffle things around. I'm going to take the 3x to the right side, I'm going to take the x to the right side, I'm going to bring the 40 over to the left side. So now we've got all the numbers on the left and all the things with x's on the right. So as you go through that, you get 84 minus 40 is 44, 3x minus x is 2x, and then you can divide by 2, and you get that x is equal to 22. So now here's where it gets a little bit dangerous, is you might think, oh great, I figured out x, I'm done the problem. No, you're not. We're not quite finished the problem yet, because now we have to go back and figure out what y is equal to. So we know x is equal to 22, but we don't know what y is equal to yet. So we take this number from x and we substitute that value back into equation 2, the one that we started with. So there's a little bit of a back and forth. You isolate the variable in one equation, you put that answer into the other equation, and then you take that answer and you plug it back into the first equation. And so then we get y is equal to 28 minus x, but we know x is 22, so we get 28 minus 22, which tells us that y equals 6. And if you're not sure if you've done it right, you take this 22 for x, the 6 for y, you plug them in here. X equals 22, so that would be 22 plus 3 times 6, which is 18, which is equal to 40. And y is equal to, y we know is equal to 6, is equal to 28 minus 22 is going to be equal to 6. So we've done this problem right. Now, about the distributive property, I just wanted to show you briefly in case you haven't seen it before. If you've got something like this, you've got a number on the outside or a variable or whatever, you've got something on the outside, and then you've got, like, for instance, something plus something, something minus something on the inside of the brackets. The distributive property says you take the number that's on the outside and you're going to multiply it by each thing that you see on the inside separately. So you've got like a multiplied by b plus c in brackets. That's the same thing as a times b plus a times c. That's what's going on in the distributive property. So if you haven't seen it before, try and internalize that now. So we've got this number on the outside and a whole bunch of stuff being added or subtracted on the inside. It's the same thing as you're like solving your problem. How you solve it is you take the thing on the outside and you multiply it by every term that you see inside the brackets, and then you just keep the plus signs and minus signs the same as they were. So if this was b minus c, then this would be a minus over here. That's okay. But yeah, the point is you just take this a and you multiply it by everything you see on the inside, and then you keep the signs the same. So that's what we used in the previous example. So now let's go through a second example. This one is a word problem, but it's going to be one that I go through with you. So suppose that the total cost of 1 kilogram of apples and 1 kilogram of bananas is 150 pesos. If you buy 4 kilograms of apples, or sorry, I shouldn't say if. You buy 4 kilograms of apples and 3 kilograms of bananas, and the total cost is 550 pesos. And you're being asked to figure out how much does 1 kilogram of apples cost and how much does 1 kilogram of bananas cost. So there's the question. You guys can think about that for a sec, but let's now move on to figuring out how to solve this. So because this is a word problem, we have to actually figure out the equations ourselves. And what we're also going to do is I'm going to pick letters to be my variables, but because I haven't been given those variables by the question, I have to write what we talked about a little bit before. I have to write a let statement. I have to say what I'm using each letter for so that somebody else who comes and reads my work doesn't get confused. So let A be the cost of 1 kilogram of apples, and let B be the cost of 1 kilogram of bananas. So there's our let statement. Now we know that A means the cost of 1 kilogram of apples, B is the cost of 1 kilogram of bananas. Great. Now we have two equations. The first equation comes from the fact that 1 kilogram of apples plus 1 kilogram of bananas costs 150 pesos. So that's our first equation here. 1 kilogram of apples plus 1 kilogram of bananas is going to cost 150 pesos. We know that. Now we also know that if you buy 4 kilograms of apples, so 4A, right? And you buy 3 kilograms of bananas, so 3B, then the total cost is going to be 550 pesos. So we've got these two bits of information. We know that if, suppose two of you go to buy some apples and bananas, and one of you buys just 1 kilogram of each and has to pay 150 pesos, and one of you buys 4 kilograms of apples, 3 kilograms of bananas, and it's 550 pesos. So those are your two pieces of information, and we have to figure out what A is equal to and what B is equal to. So this second equation has a whole lot of stuff going on. So we've got like numbers attached to both of the variables. It's going to take a little bit of work to isolate that. So instead, I'm going to isolate one of the variables from over here. We're going to isolate B, just why not, in this equation here, just because both of the letters, they don't have any numbers attached to them through multiplication or division or anything. So it's just a little bit simpler to simplify or to isolate one of the variables in equation 1. So I'm just going to put in those little labels. We'll say this is equation 1 and this is equation 2. And so now if we isolate B, then basically we just subtract A from both sides, right? So we end up with B equals 150 minus A. So now we know from this expression right here that anytime we see a B, we could instead write it as 150 minus A. All right, so with that information, we're going to go over to the second equation, the one that we didn't look at yet, and wherever we see a B right there, we're going to write in 150 minus A instead. So doing that, we had 4A plus 3B. Now we've got 4A plus 3 times this thing, and this thing right here is just B, which we found out from right over there. So hopefully that's making sense of where we got this information, right? So it was 4A plus 3B equals 550. Now it's 4A plus 3B equals 550, but B we're writing out as this, 150 minus A, because that's what this equation is telling us, right? So now what we have over here is we've got an expression that just has a whole bunch of A's in it, And that's it. No B's, no C's, no D's, right? So now we can solve for A because now this is a problem with one variable and we know how to do that. So we go through the steps to isolate A and to solve for it. So first we do a little bit of distributive property over here. We do 3 times 150, that's 450, that's this, minus 3 times A. And it's minus because we're just maintaining this minus sign. We're just going to keep that the same right here. And then we've got 3 times A, so that's 3A, that's right there. And now we can carry on with isolating and solving the problem. So we've got 4A minus 3A is A. The 450 we'll just keep here for now, equals 550, and you'll find that A equals 100. So that tells you that the cost of 1 kilogram of apples is 100 pesos. And actually, that's one thing I should have added up here is when we say cost of apples and cost of bananas, we should say in pesos, because if you don't specify that, then somebody's going to be like, okay, it costs 100 what? $100, 100 pesos, 100 something else, right? So, so we should have added this to our let statement as well. But anyway, we've now figured out that the cost of 1 kilogram of apples is 100 pesos. So now we can take that information, which we got by solving equation 2, we're going to plug it back into equation 1. So we're going to take this A plus B equals 150, but wherever we see an A, we're going to put in 100. So we got, so actually instead of plugging it into A plus B equals 150, I'm plugging it into the version where we've isolated for B. That's going to be a little bit easier, save you some steps, because then it's just a very straightforward calculation to figure out what B is. So we get B equals 150 minus A, and we know that A is 100, so we're going to get that B is 150 minus 100, which is 50. And so now we know that the cost of 1 kilogram of apples is 100 pesos. The cost of 1 kilogram of bananas is 50 pesos. And because this is a word problem, we should finish off with a therefore statement that writes out in words what the answer to the question is, because the question was posed to us in words, so we should answer in words. So we say 1 kilogram of apples costs 100 pesos and 1 kilogram of bananas costs 50 pesos. And those 3 dots over there on the left side, that means therefore. That's our therefore statement. So that's therefore, which basically means like, as a result, we can see that, like, therefore, 1 kilogram of apples costs 100 pesos and 1 kilogram of bananas costs 50 pesos. So now you can take a little bit of time to go through these 3 practice questions. And so you'll see that here, all of them, we've got X's and Y's going all over the place. So take a few minutes, work through these. That might actually take you all the way to the end of class, but try and work through these and figure out what X and Y are going to be equal to. So you can pause here, and then we will look at the answers. All right, so here are the answers to the practice questions that were listed on the previous slide. Now, because it takes so much work to go through the solution to each of these questions, I'm not going to go through the full solution here. The answers have been given for X and Y in all 3 practice questions. If you got different answers, if you got different results from the person next to you, if you all got it right, all got it wrong, whatever, take a moment, check with each other. Did you all get it right? Did somebody get it wrong? And if somebody got it wrong, if somebody's made a mistake somewhere, try and work together to understand where you've gone wrong. If somebody's gotten, one of these questions right, show everybody else what you did and how you did it. If one of you's got this question right, show everybody else how you did that, right? Just so that we can all kind of work together a little bit. So that's a little bit of the independence for you guys, is just in the interest of not making this lesson 55 minutes long. I need to go on to the word problem now to keep the lesson to within 40 minutes. But of course, if you're having questions, if you're having doubts, concerns, anything like that, just let me know and we will absolutely work through it. So here is the word problem that you can take a few minutes to work through as well. So we've got a classroom has 27 desks. Some of the desks are blue and the rest of them are yellow. There are 5 more blue desks than yellow desks. So that's saying that however many yellow desks you have, the number of blue desks is going to be 5 more than that. How many desks are there of each color? And you have the translation in Spanish as well. So take a few minutes, pause, work through it, and then we will look at the solution. All right, so let's now look at the solution to this word problem. So first things first, we're going to write a let statement. For now, it's okay if you forgot to do the let statement and you just got bogged down in doing all the math. That's okay. Don't worry about the let statements right now if that's something you forgot. The rest of the math is significantly more important. So first things first, I'm going to say let B represent the number of blue desks and Y the number of yellow desks, just so that when somebody else comes to read my work, they know that B stands for this and Y stands for that. So we now have the following two equations, and it's a little bit tricky maybe to figure out what the two equations here should be. The first one is we know that there are 27 desks in the classroom. Some of them are blue, some of them are yellow, right? But that's it. We know that that's all the desks, right? I said some of the desks are blue and the rest of them are yellow. So these two colors, however many of them are blue and however many of them are yellow, we know that in total there's 27 of them. So we say that the number of blue desks plus the number of yellow desks is equal to 27. And then we also know that there are 5 more blue desks than yellow desks. So I said that what that's telling us is however many yellow desks there are, the number of blue desks is going to be 5 more than that. So that's our second equation here. So from these two equations, we can see, we can call these equation 1 and equation 2. And we can see that in equation 2, we've already isolated B, right? Just by the way that the equation is written down, B has already been isolated. So we're going to take that. We know that B, anywhere else that we see it, like over in equation 1, we could write down y plus 5 instead of writing B. So if we go over to equation 1 where we had B plus y, I'm going to replace this B here with y plus 5. So we get y plus 5 plus y equals 27. All right, so we took the information from equation 2. We said that, okay, well, I know how to write B using y's and numbers. So over in the first equation, I'm going to write the B as y plus 5, because that's what we got from the second equation. And we get this expression right here, y plus 5 plus y equals 27. Doing a little bit of work to isolate the y, we end up with y equals 11, right? We get 2y equals 22, so y equals 11. And then from that, you can take that answer for y and plug it back over into the other equation. So we used equation 1 to figure out what y is equal to. So we take that answer and pop it back over into equation 2. And so we get that b equals y plus 5. We know that y is 11. So actually I should have written this as 11 plus 5, but it doesn't matter. And we get that b equals 16. So now we can do a quick check to make sure that we got it right. First things first, does b plus y actually equal 27? Because we know that there's supposed to be 27 desks in the classroom. And the answer is yes, 16 plus 11 is 27. And the second one, the second condition, is that however many yellow desks we have, the blue has to be 5 more than that. So the yellow desks, that's 11. Blue is indeed 5 more than that. So we can be confident that we've done this problem right just by kind of thinking about those numbers, right? And then of course, because this is a word problem, we should finish off with a therefore statement. Therefore, there are 16 blue desks and 11 yellow desks. So I hope that all made sense. I know that's a lot to try and cram into half an hour and a little bit more than half an hour. So I know I talked a little bit fast going through some of the concepts. So please, if you need more help, if you're not understanding something, if I went through something too quickly or not well enough or not clearly enough, let me know. I am thinking that our next lesson on Thursday, we'll just spend some more time working with equations with two variables, working with algebra problems with two variables, so that you get a little bit more used to it. Then after Semana Santa, we might spend a class or two going over just like a little bit of a refresher and a review session, so that you can get all set for your test, and then we'll have our test sometime either the week after Semana Santa or the week after that. So you've got a little bit of time to think about it, and you've got lots of time to reach out to me for questions. So I'm always available. Just let me know what you need, and I'll be more than happy to help. And if there are no questions, then I will see you all in the next video. Have a good one.